We learned that out means producer. Now here is the opposite question. How do we tell Kotlin that a generic type only accepts values and never produces them? How do we create a true consumer? The answer is the in keyword. What does in means? The in keyword tells Kotlin this type only consumes values. For example, interface consumer in T. Here, T can only be passed into the class or function. In makes a generic type contravariant. Creating a contravariant type without variance interface consumer of T, but with contravariance interface consumer in T. Now Kotlin will understand consumer of animal, consumer of dog can be safe. It creates safe consumer relationships. Why Kotlin allows it? Suppose open class animal, class dog extend of animal, and the consumer of animal can consume dog, cat, and bird. If somebody provides dog, everything still works. Why? Because every dog is an animal. Accepting a more specific type is safe. Safe write-only behavior. A contravariant type should only consume values. Example, interface consumer in T function accept. Notice that T appears as a method parameters here, which receiving values is safe. What Kotlin prevents? Kotlin doesn't allow interface consumer in of T, fun get and return T. Why? Because Kotlin doesn't know the exact subtype that will be returned. Imagine that consumer of animal being used as consumer of dog. Returning cat would break type safety, and in type cannot safely produce values. Example, think of a recycling bin. Recycling bin accept bottles, so you can put bottles in, but you cannot reliably ask for a specific bottle pack. The bin acts as consumer. In containers behave similarly. What in means? In T means T can only go in. The benefits save contravariance, flexible consumer relationships, compile time safety. Allowed fun accept item T. Not allowed fun get return T. Thanks for watching and see you next video.